Alright guys, in this video we'll get into chapter 3 and we'll start with 3.1 random variables. So first of all, let's take a look at the definition of random variables. For a given sample space S of some experiment, a random variable, and the shorthand version is RV, and we're going to use RV a lot in this class. A random variable is any rule that associates a number with each outcome in the sample space S. So the graph given here is explaining the definition. That means the random variable array associate each number in the number line associates a number on the number line with each outcome in the sample space, just like that. In mathematical language, a random variable is a function whose domain is a sample space and whose range is a set of real numbers. So we know how a function looks like. For example, if I give you a function f of x is equal to 2x plus 1, that means if we put one number into this function, we'll get another number out. So for example, if I put 1 in it, f of 1 is equal to 2 times 1 plus 1, so which is 3. We call this kind of thing a function. So same thing over here. We put the outcome in the sample space in the function random variable, and then we'll get a real number out. So that's pretty much the definition of random variables. Once this is clear, let's take a look at the example, and I think the example will make the definition more clear. So this example is coming from the textbook 3.1. So when a student calls the university help desk for technical support, he or she will either immediately be able to speak to someone, so in this case it denoted by S for success, or will be placed on hold. In this case, that can denoted by F for failure. Of course, the sample space will be success and failure, S and F. Define a random variable x by x of S is equal to 1 and x of F is equal to 0. So that means if we have success, the corresponding value of the random variable is equal to 1. If we have a failure, the corresponding value of the random variable is equal to 0. So this definitely coming from the definition of random variable. So associate each outcome of the sample space with a real number here. So in other words, if we say the value of the random variable is equal to 1, then we can tell this is a success. Okay? If the value of the random variable is 0, then this is a failure. The random variable x indicates whether or not the students can immediately speak to someone. So if we say it backwards, okay, if I gave you that x is equal to 1, what does it mean? That means the success, which means the student can immediately speak to someone. Right? Now what if I give it x is equal to 0? That means the student cannot immediately speak to someone. Okay? Because if the value of x is 0, that means a failure. Okay? Okay, once this makes sense to you, let's take a look at the second example here. This also coming from the textbook 3.2. Consider the experiment in which a telephone number in a certain area code is dealt under a random number dialer. Such devices are used extensively by polling organizations. And define the random variable y by y is equal to 1 if the selected number is unlisted. Y is equal to 0 if the selected number is listed in the directory. So if I give you an example, I say here's a number 528296, and I gave you that the y of this number 528296 is equal to 0. What does it mean? Okay, the corresponding value of the random variable is 0. Okay, that means this selected number is listed in the directory. So that means this number 5282966 is listed, right? Another example, another number 137628, and I gave you y of this number 137628 is equal to 1. What does it mean? So if the value of a random variable is 1, that means this selected number is unlisted. So that means 137628 is unlisted. Okay, I wish this makes sense to you. Now, once this is clear, let's take a look at this question here. Question: is there anything in common between example 3.1 and 3.2? So let's get back to those two examples. Now we can tell that in the example 3.1, the possible values of this random variable could be 1 and 0 only. I mean, the possible values of the random variable x could only be 1 and 0. Now, same thing in the 3.2, the possible values of this random variable y could only be 0 and 1. Okay, now we can tell the answer that only possible values of the random variable were 0 and 1. And for this kind of random variable whose possible values are only 0 and 1, we call it Bernoulli random variable. Let's take a look at this definition here. So any random variable whose only possible values are 0 and 1 is called Bernoulli random variable. And I just want to give you the definition here, and we're going to talk more about this kind of variable more in the future. Okay? Now, once we know the definition of Bernoulli random variable, let's take a look at the two types of random variables we're going to talk about a lot in the future of this class. And as what I mentioned in the very first video, I said that we're going to talk about two kinds of variables. One is called discrete random variables, and one is called continuous random variables. First of all, here, let's take a look at the discrete random variables. A discrete random variables is a random variable whose possible values either constitute a finite set or else can be listed in an infinite sequence, in which there is a first element, a second element, and so forth. And we call it countably infinite. So basically, as what I mentioned before, for the discrete random variable, so if we put the possible values of this kind of random variable in terms of graph, it could be a bunch of dispersed points. Okay? Just a bunch of different points. And once we know that, actually this is pretty much the same as what we went over before. And next, let's take a look at the continuous random variable. A random variable is continuous if both of the following apply. Number one, its set of possible values consists either of all numbers in a single interval on the number line, possibly infinite in extent. For example, from negative infinity to positive infinity. Or all numbers in a disjoint union of such intervals. So basically, if we put the possible values of a continuous random variable in the terms of graph, it could be in a interval, or it could be like the continuous curve or straight line, something like that. So I know that, but not. We know that if we want to determine if a random variable continuous or discrete, we just need to come up with two possible values and say if this random variable could take every number between those two possible values. For example, so if we come up with two possible values, let's say 0 and 1. Okay, so we just need to say if this random variable could take any number between 0 and 1. If it can, then it's continuous random variable. If it cannot, then it's a discrete random variable. Okay, that's pretty much the same as what we went over before. And here's number 2. No possible value of the random variable has positive probability. That is, the probability of x is equal to c for any possible value c. That means the probability of a single point of a continuous variable is always equal to 0. Why? So if we're talking about probability, let's go back to the formula. We know that the probability of A is equal to the frequency of A divided by the total, right? Now still, let's say the example between 0 and 1. Now first of all, if we want to, I want to find the probability that the 0.5 is taken. So if I randomly pick up number from 0 to 1, and what's the probability that 0.5 is picked? Now, what do we need to do? Just apply this formula here. First of all, let's take a look at how many numbers we have in this interval. That would be the denominator, right? That would be the total. So how many numbers we have between 0 and 1? So there would be infinite numbers, right? Now, how many 0.5 we have? We only have 1.5. That would be 1 over infinity, which is 0. So that's why we have the probability of x is equal to c is equal to 0 for any possible value c. So I will start this part here. Just always keep this idea in your mind. So every time if you're looking for the probability of a single point for a continuous random variable, you don't have to worry about anything. Just put 0 there, okay? The probability of a single point in a continuous random variable is always equal to 0. Why? It's over here. Just think about this example over here, okay? We get infinite numbers in the interval, and the probability one number is picked. It's going to be 1 over infinity, which is equal to 0. Okay? All right, that's pretty much all about the random variables.